quadratic function f of x is equal to the quantity x minus 1 squared minus 9, which is in standard form, we want to determine when the function is less than or equal to 0 and when the function f of x is greater than 0. So we're going to start first by looking at the function. F of x is equal to x minus 1 squared minus 9. From the function in this form, the quadratic function in this form, we can determine what the vertex is. So inside our function here is our left or right shift. And in this case, we take the opposite sign here. So that's telling us the vertex of the parabola that we will graph is at 1. And then I'll take this value exactly as it is. So the vertex of the parabola is 1, negative 9. So I'd like to start by graphing the vertex. So we're here at 1, and then negative 1, 2, 3, 4, 5, 6, 7, 8, and 9. So here is our negative 9. And this is the point 1, negative 9, which is the vertex of the parabola that we're graphing. Now what I'd like to do is to determine the X intercepts. The X intercepts are the points where the graph crosses the x-axis. So if we're on the x-axis, our y value is 0. So in order to determine the X intercepts, I can take the function x minus 1 squared minus 9 and set it equal to 0 and solve this equation for x, and that will tell me the x-intercepts for the function. So in order to do so, I'm going to isolate the x minus 1 squared, and I'll do that by adding 9 to both sides of the equation. Once I do this, I have x minus 1 squared is equal to 9. I want to get rid of that square, so I'm going to square root both sides. These are inverse operations of one another. They will undo one another. Come up here. So then I have x minus 1, and when I've introduced the square root, I'm going to take the plus or minus case. So this is plus or minus the square root of 9. The square root of 9 is 3. So we have x minus 1 is equal to plus or minus 3. So this tells me that I have x minus 1 is equal to the positive case, plus 3, and x minus 1 is equal to the negative case. So I have two simple equations here, which I'll solve for x. I'll do that by adding 1 to both sides here, and I find that x is equal to 4. The same idea here, add 1 to both sides, and I find that x is equal to negative 2. So the x-intercepts for this function are 4, 0. Recall the x-intercept is the point where the graph crosses the x-axis. That is when y is 0 and negative 2, 0. So I'm going to go ahead and plot those 2 points. So we have 4, 0, 1, 2, 3, 4, 4, 0, and negative 2, 0. So this is the low point of our parabola. And this is a quick sketch of the parabola. So the next thing I'd like to do is determine when the function is less than or equal to 0. So that is when f of x is less than or equal to 0. So this is saying when those y values are less than or equal to 0. For what x values are the corresponding y values less than or equal to 0? So I know this x value here is negative 2, and I know this x value here is 4. So the graph, our parabola here, is below the x-axis for any values between, any x values between -2 and 4. Here, this point is actually -2, the corresponding y value is 0. Here, we have the point 4, 0. So we're being asked, when is the function, when is the graph below the x-axis? So it's between the x values of -2 to 4. So between -2 and 4, between these x values, the graph is below the x-axis. And I need to determine what to do at these endpoints. The inequality is when is the graph or the function less than or equal to 0. Because of the or equal to part of the inequality, I want to use square brackets on those endpoints. At -2, the corresponding y value is 0. At 4, the corresponding y value is 0. So that's the first inequality that we were asked to solve here. The second inequality is, when is f of x greater than 0? So that is, when is the graph above the x-axis? And it's opening up slowly here. It's going out in both directions. So it's the interval in this direction, as well as the interval in this direction. So I want to name these two intervals, the interval on the left as well as the interval on the right. And this is going in that direction forever, and this is going to the right forever. So I have two intervals to name. I'll concentrate on the left interval for a moment. So reading it from left to right, that's -infinity up until whatever this x value happens to be. And it happens to be -2. So we have -infinity up until -2. The inequality is asking, when is the function greater than 0? Since it's a strict inequality, since it's greater than, I'll use a parenthesis. And so now I've named this interval here. For the right interval, it begins at 4, when x is 4, to positive infinity. So from 4 to infinity. With infinity, I'll use a parenthesis. With -infinity, I also used a parenthesis. Now, again, since it's a strict inequality, I'll use a parenthesis at 4. We have two intervals that we're joining together, so I'll use a union of those two intervals. And we have determined when f of x is less than or equal to 0, as well as when f of x is greater than 0.